There are a selection of graphs that you are expected to know, and one of them is y equals x cubed. It looks like this. Just to say, it goes for the origin because when x is 0, y is 0. As x gets bigger, y gets bigger. And when x gets bigger but in the negative direction, then like minus 10 all cubed is minus 1,000. It gets bigger in the negative direction. So it looks a little bit like it has a kind of a quadratic shape still, but actually it becomes negative here. If we then take the negative of that, y equals minus x cubed, very similar thing going on. But now where it was positive, it's going to be negative, and where it was negative, it's going to be positive. So it just basically flips around. And actually, it's a reflection in the x-axis. It's actually quite hard to do this freehand on this screen. Okay, that's not bad at all. I just need to make sure it does actually go for the origin. So there we go. In part two, we're told the curve y equals minus x cubed is translated by 3 units in the positive x direction. Now, when you get this, basically it becomes f of x goes to f of x minus 3. If it's 3, it becomes minus 3. If it was translated by minus 3, then it'll be positive 3. So you need to remember that. Essentially, it's going to the right, so you minus 3 from here as a consequence. I'm not going to go into any more detail on that. It's again a little rule to learn, but to try and understand as well. So in this case, we've got y equals minus x cubed, and then it's going to become y equals minus x minus 3 cubed. Let me just, why not talk about it very quickly, actually? So basically, I've got my x values. Let's just put a few in. Maybe a few more. So this would be 0, this would be minus 1, this would be minus 2 cubed, minus 3 cubed, minus 4 cubed, and minus 5 cubed. Okay, that is for y equals minus x cubed. Right, now if I look at y equals minus x minus 3 cubed, then what's going to happen is actually, I'm going to start over here. This would be um, minus 2 cubed because I'd do 5 minus 3 to give me 2. I would cube it and then I would make it minus. This would be minus 1. And this one would be 0. And they would end up getting, actually, this would be, well, it would be 2 minus 3, which is minus 1 cubed. And then I'd make it minus. So actually, it would become 1 cubed. And this one will become 2 cubed and 3 cubed and similar. And what I'm trying to show you is that, well, what has happened to the values? This has moved to here, and this has moved to here. So by doing a negative, I'm kind of, sorry, by putting a negative in, and basically you can see that all the y values do shift to the right because now I need a larger value of x to get what I managed to get before with 2, for example. So that's just me trying to explain why you do the opposite of what you might think. Why does minus 3 make it move to the right? Okay, his final part, describe a transformation that transforms the curve y equals minus x cubed to the curve y equals minus 5x cubed. This is a stretch. Really important to use that word. A stretch in the y direction. I think you get away with saying parallel to the y-axis as well, but I'm just going to say in the y direction by factor 5. Essentially, if you go from f of x to k f of x, then that is a stretch by factor k. And that's similar to what's happened here.